Data keeps growing since the advent of social media. This isn't a boring video about how data keeps growing. We all know that. What we don't know is that until the early 2000s, companies didn't want your data. Data was just a byproduct, but not for academia. Back then, a quiet revolution took over academic conference. Computers learning from data. Then business met academia. Amazon, Meta, Google start throwing insane money to snap up PhDs. Their goal? Turn that customer data into AI. And if you're thinking of launching an AI startup or project, you will need data too. But why? In this episode, we will define data, explain why companies want your data, and talk about data quality. What is data? Data is information and may come in the form of numbers, text, images, videos, and so on. Examples of your data include your step count, your browsing history, how many minutes you've listened to Beyonce on Spotify. Hello, Beehive. And thanks to Silicon Valley, hometown, any piece of information or data can be represented digitally as a series of zeros and ones, known as bits. When there's a huge amount of data, we call it big data. Big data is so large that it can be analyzed by traditional methods like Excel spreadsheets. Think about the number of passengers who fly every day with an airline company. For example, United Airlines flies about 400,000 people per day. Picture all the information with these passengers. Names, ages, destinations, ticket prices. Now imagine this data accumulating over a year. That's big data and can be handled by Excel, which, fun fact, is limited to just over 1 million rows per worksheet. Data is measuring bytes, and you know that because when you buy an iPhone or a Galaxy, you choose the memory size. 128 gigabytes, 256, 512 gigabytes. You're essentially picking the capacity of digital data, photos, videos, apps that your smartphone will store. Guess the amount of data in the world. It reached 64.2 zettabytes in 2020. That's like every person in the world having 15 iPhones of the big ones. And it's expected to reach 181 zettabytes by 2025, or like 45 iPhones per person. Why do companies want your data? Interesting quick story. Up until the late 90s and early 20s, data was just a byproduct of business operations. Back then, most companies stored data because they had to, for record keeping, for internal process. More data meant one thing: more storage costs. But around the turn of the millennium, new developments brought change. First, digital storage was getting cheaper. Cloud computing was emerging, hard drivers were doubling capacity. Then came the explosion of the internet. People were connected like never before, generating vast quantities of data with every click. Companies found themselves with mountains of data. Data that was just sitting there, waiting. And here is where things get interesting. If this was a Hollywood plot thickens. Computer scientists from universities like Stanford, MIT, University of Toronto start revisiting AI concepts from the 80s and applying to these large data sets of the digital revolution. Increasing computation power also played a key role here, but that's going to be a theme for another episode. These researchers were publishing breakthroughs in machines learn from data, finding patterns that humans couldn't see. Guess who start reading research papers? Companies began to take notice and start reading voraciously these academic papers. They began to realize that their vast source of data on customer behaviors, transactions, customer preference was way more than record keeping. If computers could learn from this data, they could predict trends, personalize services, automate decisions in the ways that seems almost magical. And so the worlds of academia and business began to merge, all thanks to machine learning. Machine learning is a subset of artificial intelligence where computers learn to identify patterns without any specific instructions from humans. Instead of being directly programmed, the machine learns from the data itself, hence machine learning. And why is revolutionary? Because for complex tasks like translation or customer behavior, it's nearly impossible for a human to write an algorithm that a computer could then follow. Imagine writing a translation codes algorithm from English to Portuguese. You would need to account for like countless grammar rules, figure of speech, context, culture nuances between the two languages. Each exception and each variation would require its own set of instruction. The task would be practically impossible for traditional programming methods. But for all these tasks, it's relatively easy to collect a large amount of data. And with large quantities of data, a computer can be trained. There is a saying in the computer science community, which I'm definitely not a part, that says, once you were smart, you invented a new algorithm. Now, if you're smart, you find a new source of data, possibly by writing an app. You might be using an app whose entire goal is just your data. The belief behind machine learning is that computers can learn in ways that mimic how humans learn, by seeing examples, recognizing patterns, making mistakes, learning from those mistakes, and gradually improving. And let me tell you, machines definitely improve way faster than humans. I've been learning English since I was 10, not going through all the grammar, gosh no, binge watching Friends like any Brazilian, and still struggling. Meanwhile, Google Translate, not perfect, but good enough and superbly fluent in 243 languages. So what machine learning is very good at? Two main tasks. Prediction. Machine learning models can forecast future outcomes like predicting sales trends or customer churn. And the second thing, classification. These models can sort information into different categories, such as spam, not spam, fraudulent transaction, genuine transaction. Data quality. There is no AI until the data is fixed. The quantity of the data is very important for the model to learn effectively and from different scenarios. But as important, if not even more important, it's the quality of the data. AI doesn't differentiate between good or bad inputs. If the prices in our data are wrong or if they're old, our model will not be accurate, and this can be very costly. Data needs to be cleaned up, a process known as data hygiene. The main issues to address are missing values, inconsistent formats, such as like currency, time zones, units of measurements. Third, noise. Remove any extreme values known as outliers or irrelevant data, any feature that don't contribute meaningfully to the model's predictions, and remove any duplicate records. Of course, data perfection is almost impossible to achieve, but data can be refined to be good enough. Once you have a clean information as a base, your AI won't be misled by incorrect data like United Airlines was a few years ago. Bad data costs United Airlines $1 billion annually. United built software called Orion almost 20 years ago to help forecast demand for seats at various prices. United's big data is really big. As a result, United can only store 2 years of historical information, a limitation that has real-world repercussions. This year, Christmas is a Sunday. That's a huge change in demand patterns. We don't have data in our system to go back and tell us what happened 5 years ago, the last time Christmas was on a Sunday. United software also is designed for how the industry operated 20 years ago, when there was a clear distinction between business and leisure travel that was easy to detect because airlines require weekend stays for the cheap leisure fare. That line is now blurred. Guarantee a trustworthy AI model, it comes down to large data sets, high quality data, and unbiased data. I did an entire episode on AI bias, so if you're interested, check it out. Machine learning kicked off the data is the new oil era. But like oil, data is only valuable when refined. Super cheesy, but it's so true. You need high quality data. With machine learning, a field that has been around for decades, data now drives entire operations. Business is capturing data from everywhere to build machine learning models. And while you might assume this process is super elegant, I'll break it to you. Machine learning is based on trial and error. But why?